Hi guys, welcome to lesson 7.1. In this lesson, we're going to be talking about solving differential equations. Now, a differential equation is an equation with a derivative inside it. So if you look at all these examples, I have a derivative inside my function. So, if I want to solve this type of equation, we have these steps listed here. I'm just going to show you these steps in this example. The first step is to rewrite y prime as dy dx. Very important. It's already written that way in example 1, so we're good. Now, here's the next step. I need to separate these variables, which means I need to have dy on one side and dx on the other side. So usually the best way to do that is to take your whole equation and multiply it by dx. Now this one I have to distribute, so I'd get x dx plus 2y dy, because those dx's would cancel, equals 0 times dx is 0. So now I've separated the dy and the dx. Now, really important next step is to separate the variables, meaning I need all my x's on one side and all my y's on the other side. So I'm going to get my x's over to here. Now, we know we're ready for the next step. If we check this, all the y's are on one side with our dy, and all the x's are on the other side with our dx. If that's the case, then you can move on to the next step, which is to integrate both sides. And now you can see why we had to get the dy here and the dx there, because that's what's necessary for the integration. So let's integrate this. 2y is going to be 2y squared over 2 equals, this one's going to become negative x squared over 2. Now, these are indefinite integrals, so we should have plus c's. However, I'm going to do something a little different here. Those c's are just a number, right? They're called the constant of integration. It's a constant. It's a number. So if I have a number here and a number there, couldn't I also just combine them to one number here? And you can totally do that on the AP test as well. You don't need separate c's for each of them because c is just a number. And I could say c is one number as well as I could say c is two numbers. So we're just going to do one c for one constant of integration instead of one for both, because then that makes everything more complicated. So I've got here, let's simplify this. So I got y squared equals negative x squared over 2 plus c. And that is our answer. Now, be careful about one thing, and we can see that in this next thing. It says, write your solution to example 1 as a pair of possible functions. This is a key word you're going to want to look out for this kind of problem, because this equation right here is not a function, meaning if you graphed it, it doesn't pass the vertical line test. If it asks for a function, or it could say in the form y equals f of x, that's the same thing, either of these two things. If it says function or in the form y equals f of x, that essentially means you need to solve for y. That's what that means. So if I want to take this equation and I solve it for y, then I take the square root. But remember, anytime you take the square root, you get a plus or minus. So I get a positive square root of negative x squared over 2 plus c, and a negative square root of negative x squared over 2 plus c. And those are my answers down here, because these ones are now functions. They would pass the vertical line test. So essentially, if it says function or in the form y equals f of x, that tells you you need to solve for y. If it doesn't say either of those things, like here it just says find a general solution, you don't need to solve for y. You can leave it right there like that. Okay, let's try example number 2. Find an equation of a function, so that tells us we need to solve for y, which contains this point. So that right there is how we solve for plus c. That's what that's saying. And whose slope is this. So if the slope is this, we know slope is just another word for dy dx. So here we have slope, we have derivative equals this equation. I need to solve this. So remember, first step, you need to get x's on one side and y's on the other side. So let's multiply everything by dx. So now my dy is on one side, and my dx is on the other side. Then I can times by y to bring my y's all to one side and my x's all to the other side. Now double check. Y's and dy's on one side, x's, dx's on the other side. Check. So now I can integrate. Now, I want you to actually try this integration on your own. This one is a pretty simple one. This one is going to be a u substitution. So be careful on that. But I want you to pause the video and try both of those integrations on your own, and then come back to check and see how you did. Let's see how you did. Integral of y is going to be y squared over 2. This is going to be my u, so du is 2x dx, so I add a 2, so I get my du, and a 1/2 outside, so I get 1/2 integral of e to the u when all that's plugged in. Well, the integral of e to the u is just e to the u, and there's my u with the 1/2 still in front, and my plus c. Now, this one, we need to do 2 more things. Number 1, I need to solve for c, and then I need to solve for y so that it's a function. So let's plug in y is 0 and x is -3. Oops, sorry, mixed that up. Y is -3. There we go. And x is 0 to solve for c. So this is going to be 9/2 equals 1/2 e to the 0, which is 1, because anything to the 0 power is 1. So this is just going to equal 1/2 plus c, minus 1/2 is going to be 8/2, which is 4. So now I've got y squared over 2 equals 1/2 e to the x squared plus 4. I know what c is, but it's still not a function, so I need to solve this for y. So let's times all this by 2. Don't forget, I need to distribute that. That looks like a squared. Not a squared times by 2. Let's do that. So 1/2 times 2 is just 1. 4 times 2 is 8. And now I need to square root it. So I'm going to get y equals plus or minus square root of e to the x squared plus 8. And that is my function. I solved for c. I should be good to go. Okay, in the next video, we're going to try 2 more examples of this differential equation stuff. And then we'll have one more video where we talk about plugging in solutions.